next problem we have here. Okay. All right, let's take a look at the next problem we have. This is very similar to the previous problem. It's asking us to find the current through R3 now. So same currents. This is I3. And then we have the same values as last time. However, I is in a different location. So this will still be 10, this will still be 20, this will be 15, and then this will be 10 again. And then just as before, this is all in parallel. And if we're breaking up the current, we're going to do a current division. And the equation, like we said before, R equivalent over R number times IS. So source current that's being broken up. So let's take a look here and see what this current is going to do. So if we know this current value, then what we can say is that we know it's going to come over here, hit here, break off and go this way, break off and go that way, break off, go down to I3, travel through there, and then meet back up, and then meet back up. Okay, to where it forms I again. So we see that this current is now only being broken up across 3 resistors. So this is going to be our R parallel now. So R parallel this time is going to be 1 over 10 plus 1 over 15 plus 1 over 10. And what does that come out to be? And this is actually supposed to be 20. And this will give us 4.615 ohms. So therefore, if we were to find I3 now, it would be 4.615 over 15 times 20 amps. It's this time it's 20 amps, not 10 like the previous one. And that gives us 6.15 amps for IF3. Okay. So now, if we wanted to find, let's say, IF4 over here, all we would have to do is IF4 is equal to 4.615 over 10 times 20 amps. And what would that give us? This will give us 9.23 amps for I4. Okay, so just showing you that you can use the R parallel to find 1, 2, 3 currents. You know what, while we're here, let's just go ahead and find I2. So I2 is going to be 4.615 over 20 times 20 amps. And those two 20s will cancel out, so it'll give us 4.615 amps for I2. And then if you were to add all 3 of these back together, you would end up with 20 amps. which checks out.